Our story begins long ago, far beyond human memory, before time itself as we know it. Imagine an existence without stars, without galaxies, without even the space between them. This is the ultimate mystery. How did everything come from nothing? Science offers us a glimpse, a theory, a starting point for an incredible journey. It is a journey that leads to us, to our world, our Earth. We look up at the night sky, we see countless stars, each one a distant sun. Our universe is vast, almost beyond comprehension, yet it all had a beginning, a moment of creation. Scientists call this moment the Big Bang. This is not just a story, it is a tale written in the fabric of the cosmos. We are still learning to read its ancient script. Every discovery brings us closer to understanding. Think about the grandest questions. Where did we come from? How did our home, planet Earth, form? These questions have puzzled humanity for ages. We search for answers in the stars. We dig for clues beneath our feet. The epic tale of Earth's creation is a scientific detective story. It connects the smallest particles to the largest structures in the universe. Join us as we explore this amazing story. Our universe is a dynamic place. It is constantly changing, constantly evolving. The birth of Earth is just one chapter, but it is a chapter crucial to our own existence. From a fiery beginning, our planet transformed. It became a haven for life, a blue marble suspended in the vastness of space. Let us travel back to the very dawn of time, to witness the universe's first light. The Big Bang was not an explosion in space. It was an expansion of space itself. Imagine a point, infinitely small, infinitely dense, containing all energy, all matter. This was the state before the universe began. Then in an instant it started to expand rapidly, unimaginably fast. This was the birth of space, the birth of time. In the first fractions of a second, the universe was incredibly hot, a soup of fundamental particles, too hot for atoms to form. As space expanded, it cooled. This cooling allowed particles to combine. Protons and neutrons appeared. These are the building blocks of atomic nuclei. The universe was still a dense, foggy plasma. Light could not travel freely. It was a very different place. After about 380,000 years, a crucial change occurred. The universe cooled enough for electrons to join nuclei. This formed the first atoms, mostly hydrogen and helium. Suddenly, the universe became transparent. Light could finally travel across space. This first light is something we can still detect today. It is called the cosmic microwave background radiation, a faint glow from our universe's infancy. This expansion continues, even now. Galaxies are moving away from each other. The universe is getting bigger. The Big Bang theory is supported by much evidence. The cosmic microwave background is one piece. The abundance of light elements like hydrogen and helium is another. The observed expansion of the universe confirms it. It is our best explanation for how it all began. A truly epic start. After the Big Bang, the universe was mostly hydrogen and helium gas. For millions of years, gravity began its slow work. It pulled these vast clouds of gas and dust together. Denser regions formed. These regions grew larger and larger. As they collapsed, their centers became hotter and denser. This was the beginning of star formation. The universe started to light up. The theory explaining this process is called the Nebula Hypothesis. It suggests that stars and planets form from giant molecular clouds. These clouds are cold and dark, but within them gravity is a powerful force. It causes clumps to form. These clumps spin. As they spin, they flatten into disks, like a spinning pizza dough. This is a common process throughout the cosmos. At the center of each spinning disk, a protostar forms. This is a baby star. It is not yet shining by nuclear fusion, but it is hot, very hot. It gathers more material from the surrounding disk. Its gravitational pull increases. The pressure and temperature at its core rise steadily. This process takes millions of years, a slow cosmic dance of matter and energy. Eventually, the core of the protostar becomes hot enough and dense enough. Nuclear fusion ignites. Hydrogen atoms begin to fuse into helium. This releases a tremendous amount of energy. A new star is born. It shines brightly, pushing away some of the remaining gas and dust with its stellar wind. The surrounding disk, however, still holds the raw materials for planets. Our own solar system formed this way. Our sun, the star that gives us life, it too was born from such a cosmic cloud about 4.6 billion years ago. A vast nebula of gas and dust swirled in our corner of the Milky Way galaxy. Perhaps a nearby supernova explosion sent a shockwave through it. This shockwave could have triggered its collapse. Gravity then took over, pulling material towards the center. As this cloud collapsed, it began to spin faster, just like an ice skater pulling in their arms. Most of the material gathered in the center. This formed our protosun. The remaining material flattened into a vast rotating disk. This was the protoplanetary disk. It stretched out for billions of miles. Within this disk, the story of Earth and its sibling planets began to unfold. It was a chaotic, dynamic environment. The young sun blazed at the center. Its heat was intense. Closer to the sun, only rocky materials could withstand this heat. Further out, it was colder. Icy materials could also survive. This created a separation. The inner solar system would form rocky planets. The outer solar system would host gas giants and ice giants. This temperature gradient was crucial. Tiny dust grains in the disk began to stick together. Static electricity played a role. Then, small clumps attracted each other through gravity. These clumps grew into larger bodies called planetesimals. Some were only a few feet across, others grew to be miles wide. These were the seeds of planets. Countless collisions occurred, some destructive, some constructive, building planets piece by piece. Section 5, a special rock Earth's violent formation. Our Earth did not form gently. It was a process of violent collisions. Planetesimals crashed into each other, merging and growing larger. Over millions of years, these collisions built up protoplanets. Early Earth was one such protoplanet. It was a chaotic and dangerous time in the young solar system, a cosmic shooting gallery with debris flying everywhere. One of the most significant events in Earth's early history was a giant impact. A Mars-sized object, sometimes called Theia, collided with the young Earth. This was a cataclysmic event. The impact was immense. It would have melted much of Earth's surface and ejected a vast amount of debris into orbit around our planet. This debris eventually coalesced and formed our moon. This giant impact theory explains many things. It explains the moon's relatively large size compared to Earth. It explains why the moon's composition is similar to Earth's mantle. It also tilted Earth on its axis, giving us our seasons, a profound consequence of an ancient cosmic collision. The moon's presence also stabilizes Earth's rotation, which has been important for long-term climate stability. So, our Earth and Moon are cosmic siblings born from a dramatic event. After this giant impact, Earth was a molten ball of rock. Its surface was a sea of lava. Heavy elements like iron and nickel sank towards the center, forming Earth's core. Lighter materials floated upwards, forming the mantle and eventually the crust. This process is called differentiation, and it shaped our planet's internal structure. Section 6, the Hadean Hell, Earth's molten infancy. The earliest period of Earth's history is called the Hadean Eon, named after Hades, the Greek god of the underworld. It was a truly hellish time. Earth was incredibly hot. Its surface temperature was thousands of degrees, a glowing molten sphere. There were no oceans, no continents as we know them, just a roiling sea of magma. The young Earth was constantly bombarded. Asteroids and comets rained down from space. These impacts added more material to Earth. They also generated more heat, keeping the surface molten. The atmosphere was very different too. It was thick with gases released from the cooling rock, gases like carbon dioxide, water vapor, and nitrogen. But there was very little oxygen, not a place life could survive. Imagine this fiery landscape. Volcanoes erupted constantly, spewing lava and gases. The sky would have been dark and hazy, lit by the glow of molten rock and frequent lightning. The moon was much closer to Earth then. It would have appeared huge in the sky. Its gravitational pull would have caused enormous tides in the molten surface. A truly alien and inhospitable world. Gradually, over hundreds of millions of years, Earth began to cool. The constant rain of large asteroids lessened. Heat from the planet's formation started to radiate out into space. As the surface cooled, a thin, rocky crust began to form, like a skin on cooling pudding. This was the very first solid ground. But it was fragile, often broken up by volcanic activity and impacts. Section 7. Cooling down, the first oceans and atmosphere. As Earth continued to cool, a remarkable transformation began. The water vapor in the thick atmosphere started to condense. It began to rain, not just a shower, but a deluge that lasted for centuries, possibly thousands of years. This relentless rain fell upon the cooling crust. Water collected in low-lying areas, forming the first shallow seas and oceans. These early oceans were very different from today's. They were likely much hotter and more acidic due to dissolved gases like carbon dioxide. They would have been a brownish color from dissolved iron, but they were water. Liquid water, a crucial ingredient for life as we know it. The presence of liquid water marks a major milestone in Earth's journey to becoming a habitable planet. The atmosphere also began to change. As oceans formed, they absorbed a lot of carbon dioxide from the air. This reduced the greenhouse effect, helping the planet to cool further. Volcanic activity continued to release gases, but the composition of the atmosphere was slowly evolving. It was still not breathable for us, but it was taking steps in that direction. The formation of the first stable continents also started around this time. Lighter granitic rocks formed through complex geological processes began to accumulate. These formed small landmasses called cratons. These ancient cores of continents are still found today. Earth was no longer just a molten ball. It was developing distinct features, oceans, land, and a changing atmosphere. The stage was being set. Section 8. Seeds of life. Earth becomes habitable. With liquid water and a cooling surface, Earth was becoming more hospitable. But when did life begin, and how? This is one of science's biggest questions. The earliest evidence for life dates back to around 3.5 to 3.8 billion years ago. These are microscopic fossils of simple, single-celled organisms found in ancient rocks. Life appeared relatively early in Earth's history. The exact process of abiogenesis, life arising from non-living matter, is still a puzzle. Scientists believe that the early oceans, rich in organic molecules, were a primordial soup. Energy sources like lightning or ultraviolet radiation from the sun could have triggered chemical reactions. These reactions might have formed the basic building blocks of life: amino acids, nucleotides, complex molecules forming by chance. Another theory suggests that life might have begun near hydrothermal vents. These are cracks in the ocean floor. Volcanically heated water, rich in minerals, gushes out. These vents create unique chemical environments. They provide energy and raw materials. Perhaps these deep-sea oases were the cradles of life, sheltered from the harsh conditions on the surface of early Earth. We continue to explore these possibilities. Over billions of years, life slowly transformed the planet. Early photosynthetic bacteria began to produce oxygen. This was a revolutionary change. Oxygen was toxic to many early life forms, but it also created new opportunities. It led to the formation of the ozone layer, protecting the surface from harmful UV radiation, paving the way for more complex life to evolve. Earth was truly becoming a living planet. Section 9. An unfolding story, mysteries that remain. We have journeyed far from the Big Bang's first light to the cooling of a molten Earth, to the dawn of life itself. The story of our planet's creation is vast. It is a testament to the power of natural forces acting over immense timescales. Science has pieced together many parts of this incredible puzzle. But the story is not yet complete. Many mysteries still remain. The precise details of how planets form are still debated. How did tiny dust grains grow into massive worlds? The exact timing and nature of the giant impact that formed our moon are subjects of ongoing research. And the biggest mystery of all, how did life begin? What was the spark that turned non-living chemicals into the first living cells? These questions drive scientific exploration. We continue to learn more every day. New telescopes peer deeper into space. They're observing distant solar systems in the process of formation. Spacecraft explore other planets in our own solar system, giving us clues about planetary evolution. Geologists study Earth's oldest rocks, uncovering secrets from its deep past. Each discovery adds another piece to the grand narrative. The epic tale of Earth's creation is also our own story. We are made of stardust, forged in the hearts of ancient stars. Our planet provides the perfect conditions for life as we know it. Understanding its past helps us appreciate its present, and perhaps to safeguard its future. The universe is full of wonders, and the story of Earth is one of its most remarkable chapters. Still unfolding, still inviting us to explore.